We've seen that both the range and the interquartile range give us reasonable ways of measuring the variability of a data set, but they're a little bit crude, so they only use two values, and in the case of the range, it can be quite heavily affected by outliers, and so in some situations it cannot give us really good information. In fact, it can give us misleading information. So the question is, can we do better? Well, what does that mean? Well, we're going to ask, can we do one of the following, namely, or many of the following? Can we find a measure that uses all data? And can we base it on some formula whose calculations are not that complicated? And also, can we, once we do that, can we obtain a statistic that can be used in other situations, not just for the sake of computing it, but can be used in other situations? Well, the answer to these questions is yes, it can be done, and the solution has been obtained by a mathematician by using what is called the standard deviation that you probably have heard of before, and probably you have seen it before. And the standard deviation is given by one of these formulae. Well, if the data is obtained from a sample, we're going to use this formula, the square root of the sum of the squares of the differences between each of the values and the mean, all divided by n minus 1. And so this is what we get if we're using sample data. On the other hand, if we're able to get data from the whole population, we use the same formula, but we use an n in the denominator. Does that make sense? Okay. Probably at this point you're looking at that formula and you're screaming just like the fellow in the famous painting. Now, why is that? That formula, even though I said that this involves very easy calculations, and it is true, but is a formula that probably has plagued students in high school for a while. It is not very easy to work it out by hand. So why do people use the standard deviation? Oh, first of all, at some point in the if you're interested in knowing where that formula comes from, in the textbook there's a little appendix where I discuss that, and hopefully in the near future I'll make a video just for that one. For now, don't worry about it, because it's not really that important. What is important, however, is understand why this formula is useful. What's good about this formula? And why do we use the standard deviation so much? Well, first of all, it is a measure of variability. It does tell you how far the data are from each other. Notice that actually not so much from each other, but how far the data are on average from the mean. So it is a measure of variability. Also, it uses all data. It's the sum of all the differences between each of the data and the mean. And believe it or not, it's simple to compute. Not by hand necessarily, but even by hand there is a simpler formula to obtain the same result. But certainly for a computer, it's very easy to program. Okay, so, and remember, one of the other criteria that I mentioned was they had to be usable. Well, it turns out that the standard deviation is very useful in inferential work that we're going to see later on in the course. But, and this is a big but, didn't mean it as a joke, but it is a but. What happens is that this standard deviation is not very good as a descriptive measure. It's difficult to look at a standard deviation and really understand what it means. So if in the past you have been confused by the standard deviation, there is a good reason. The standard deviation is not easy to understand intuitively. It does not give you as simple an interpretation as the range, right? The range is minimum, maximum, that's it, very easy. The standard deviation, what does it exactly mean? Not clear. In fact, the standard deviation is often misinterpreted, and we're soon going to have a look at some of the common ways in which it is misinterpreted. And the other thing is, because it's so famous, it's often reported, but for no useful reason. So we're going to see the standard deviation reported in many articles, and you wonder, why did they report it? Not clear. So what we're going to do next is we're going to have a look at some common misconceptions, and make sure that you're not going to fall into those same misconceptions. And then we're going to leave the standard deviation a little bit alone, just to we're going to wait to use it until we get into inferential work, because that is where the standard deviation really shines. So we'll come back to it at that point.